Hello students, myself Sumangla Virata. In previous video we discussed about the relational algebra concepts. Now in this video let's see about mapping conceptual design into a logical design. So relational database design using ER to relational mapping. So ER we call as a conceptual designing and relational mapping is a relational concept here. So you already know that you already learned about conceptual data modeling also and relational data modeling also. Now we learn how these two are related. First steps, you are having the 7 steps in this mapping. First one is the step 1, mapping of regular entity types. So first what are the, in conceptual data model you are using the term as a entity types, and how you are mapping this regular entity types to relational data model, that one comes under in this step 1. Next is step 2, mapping of weak entity types. So in the conceptual data model you are using one more term as a weak entity types. So if that entity type is not having its own key, so such type of the entity types we call as a weak entity types, and how we can map this weak entity types into a relational data model, that is the step 2 here. Next step 3 is the mapping of binary 1:1 relation types here. This is one of the coordinate ratio, so that is the step 3 here. Step 4 is mapping of binary coordinate ratio 1:n of the relationship types into a relation. Step 5 is mapping of binary m:1 relationship types here. So next, mapping of multi-valued attributes. As I told earlier, so in relational data model, it doesn't support multi-valued attributes because in the relational data model, domain must be atomic. Okay, domain must be atomic means what? It doesn't support composite and also it doesn't support the multi-valued. Then how you are mapping this with the multi-valued attributes of conceptual data model into relational model? Let's see. That is your step 6. Next is step 7, mapping of n-array relationship types here. More than two relations if you want to relate, that one we call as a n-array relationship types here. These are the 7 steps if you want to map the designing of ER to relational mapping here. Let's see one by one. First is mapping of regular entity types. This is your conceptual data model, designing is ER diagram, and this is your relational data model, designing is the schema here. So in this one we know that these are the entity types and these are the attributes of the entity types. Whereas in relational data model you are using as a employee, department, all these are the name of the relation and these are the attributes here. So this is what we call as a mapping of regular entity types. So what are the entity types you are having? Employee as a one entity type, that one you are taking as a one relation. Department as another entity type, and that one we are taken as a another relation. For all the entity types you are taken as a different relations. So this is first step, how you make the mapping of regular entity types. So all the regular entity types you are taking as a relation in relational data model. Next is mapping of weak entity types. So here as you know that dependent is the weak entity type. So here you don't have the key of its own here. So that's why dependent is the weak entity type. And you are relating this to using what? Dependent as a weak relationship type here. Now you have to map this with the your relational data model. So in relational data model, so now how you are mapping? So you are taking the attribute, primary key of the employee table, and one of the attribute of the dependent table as a combination, and combination of this two you will take as a primary key here. So in the employee table, SSN is the primary key. That SSN you are taking as a primary key in the dependent table, and in the dependent table also you are having the one of the attribute dependent name, because dependent table don't have its own key. This dependent name is the secondary key here. So this is the attribute of dependent table, and ESSN is the primary key of the employee table. Combination of this two you will take as a foreign primary key in the dependent table. This is how you make as a weak entity type. So in any table, one thing you remember, in any table, if you take the combination of multiple attributes as a primary key, it indicates what? That is the weak entity type. Okay, as a, that relation is not having its own, okay, key attribute here. That is what we call as a mapping of weak entity type. SSN primary key, it is the employee table. Whereas in the dependent, combination of two attributes you are taking as a primary key. So it tells that what dependent is a weak entity type and it is not having its own key here. In this way, you make the mapping between the ER and the relational data model. Is it clear? Okay. Next is mapping of binary 1:1 relationship types. So now for mapping this 1:2 relationship type in the ER schema, R is the one relation, it identifies relation as a S and T. Okay. So now here foreign key approach, you can specify, okay, mapping, how to map the binary 1:1 relationship types. One approach, you can go for foreign key approach. Foreign key approach, it tells what it is. Choose the relation S and include a foreign key S, that is the primary key of T here. So if in the 1:1, so this is one relation, S is one entity type and T is also one entity type. In relational data model, S is one relation, T is also one relation here. So in the S, what are the relation you are having? So same primary key you take as a foreign key in the another relation T here. So such type of the approach we call as a foreign key approach. Here it is the example. 1:1 relation, where it comes? It comes under the managers. Okay, how you are mapping? You are mapping department. So in the department, this a manager SSN play the role of the manager. So that manager SSN is the foreign key. Whereas in the employee table, SSN is the primary key here. Okay, so that primary key you are including in the department as a foreign key here. Okay. So this is what we call as a foreign key approach here. One more approach is there, merged relation option. Merged relation operation, just you have to merge the two entity types and their relationship into a single relation. You can merge the both the relations as a single relation here. So S and T you can merge as a new relation R here. That type of the concept we call as a merged relation option. Cross-reference or relation option. In the relationship operations, once again you are taking the three relations here. S is one relation and T is another relation. 1:1 relation mapping if you want to specify, no. So then you create one more new relation as a R and that must be contain the primary key of S and also primary key of the T, and combination of this two you take as a in the R as a primary key here. So that is what we call as a cross-referencing the primary key of the two relation S and T representing the entity types here. So this is about mapping of 1:1 relationship type. One is foreign key approach in S primary key and T primary foreign key if you take, that is what we call as a foreign key. Merged, both you merge as a single relation. Cross-referencing, create a one more new relation. In that relation, both the relation primary key you take as a foreign key. Mapping of binary 1:n relationship types here. For each regular binary 1:n relationship type R, identify the relation S that represent the participating entity type at the end side of the relationship type here. So it includes a foreign key in S, the primary key of the relation that represents the other entity type participating in R here. It includes only simple attributes of 1:n relation types as attributes of R here. It is very simple. If you take as a 1:n relationship types, example for that one is works for, controls, supervision. So in works for, we include the primary key, T number of the department, relation as a foreign key in the employee relation, that is we call as a TNO. So here where you are having the one relation, so in that one relation you have to take as a primary key, and end relation it is what you are having, no. So in the end side you have to take as a foreign key here. So you are using the primary key and foreign key of the two entity types, and based on that you have to decide, you take the number of n employees can work for the one department. So then in the employee table, so you take one attribute as a foreign key, and next in the department table all employees must work for any one department. So that's why in the department table for the works for, you have to take D number as a primary key here. So in the department, number is the primary key, because for one department n employees can work here. Where in the employee table, so same department, more than one employees may be there here. So that's why you have to take in the form of 1:1 n relationship. Mapping of binary M is to N relationship types. If it is M is to N relationship types, for each regular binary M is to relationships, you have to create a new relation. So that relation contains the combination of the earlier two relations primary key here. So now this R is the relation. If you want to specify, new relation S you have to take. In the S, you have to take as a foreign key, and primary key is what it is. Primary key is the combination of the two participating entity types. So for that example is works on. So works on contains the two relation. It is combination of the project and employee. So there is the relations between project and employee as a M is to N. So more than one employee can work for same project. Same project may also contain more than one employees. In both the side it is M is to N here. In that situation, you have to create a new relation S as a works on. So what S works on contains? Attributes of works on are, so primary key of project table and primary key of employee relation. So these are the primary keys. PNO is the primary key of the project and SSN is the primary key of the employee, and these two things you take as a foreign key in the new relation as a works on here. This is about the mapping of M is to N relationship types. Next is mapping of multi-valued attributes. As I told, it doesn't support multi-valued attributes. Then you have to create a new relation. That relation, what it makes? So here I taken the example of department location. This is the new location, the location. So primary key of the department table, and one of the attributes you have to take as a department location, and combination of this two you can take as a new relation, because it does not support multi-valued attributes here. So then what is the thing? Which attributes violates that multi-valued concept? That attributes you have to extract from department table, and you have to create a new relation, like department location. Along with that you have to take the primary key of the department table here. That new relation, which attribute violates or which attributes holds multi-valued, that one, and along with that, so our relation key, primary key attribute, you take as a new attribute, new relation attributes here. That is of mapping of multi-valued attributes. Next is mapping of n-array relationship types. If n-array relationship types are indicates what? N value is greater than 2 here, other than binary. Number of entity types involved in relating the relations are more than 2, then you call that as a n-array here. So more than one relations if you want to relate, no, then each entity types you take as a one relation, and in each relation what are the primary keys you are having, no, all those primary keys you have to take as a foreign key in the new relation here. Example here. So this is your supplier, project and part are the three entity types. That one you are mapping as a relation, supplier, project and the part here. To relate this thing you are using relationship as a supply. So in the supply you have to create as a new relation, and here attributes are what here? Primary keys of the all these relations. Supplier primary key is S name, project type primary key is project name, and part primary key is part number. All these are the foreign keys in the new relation as a supply here. Okay, and how quantity is you are taking as a one additional attribute for this supply here, and combination of these three you take as a primary key here. Individually it is foreign key here. Each relation primary key you take as a foreign key in the new relation. That is about mapping of n-array relationship types here. Is it clear now? Okay, thank you.